Good morning, dear students. Today we are going to discuss characteristics of simple harmonic motion. Dear students, we know that simple harmonic motion is that motion in which acceleration is directly proportional to negative of displacement, and simple harmonic motion is the periodic motion. All the simple harmonic motion are periodic motion, but it is not necessary that all the periodic motion must be simple harmonic motion. So today we are going to discuss some characteristics of simple harmonic motion. So let's discuss them one by one. Our first characteristic is displacement. The distance traveled at any instant by the body or particle executing simple harmonic motion from its mean position is called the displacement. So let's see, from here we have the particle, and this particle starts from the x and moving with the constant velocity omega in the circular path of radius r. At any instant this particle is at point P. This is the P point. This point is also known as the reference point, and when the particle is moving in the circular path, we see that r is the radius of circular path, and from point P we drop a perpendicular from here, and m is the projection of this point P. So from point O we see that OM is equal to y. OM is equal to y. What does y represent here? Y represents the displacement of projection of particle executing simple harmonic motion. What does y represent here? Y represents the displacement of projection of particle executing simple harmonic motion. So from figure we see that from right angle triangle OPN, what is sin theta? Sin theta equals to perpendicular upon hypotenuse. So perpendicular PM, this is equal to y upon hypotenuse, this is equal to r, y upon r, and y is equal to r sin theta. And what does theta represent here? As we know that angular velocity omega is equal to angular displacement upon time. Omega is the angular velocity, theta is the angular displacement, t is the time. So theta is equal to omega t. We put this value here. This is number 1, this is 2. Using 2 in 1, we get y is equal to r sin omega t. Y is equal to r sin omega t. So this is the equation 3. Y is equal to r sin omega t. This equation represents the displacement of the particle executing simple harmonic motion. If we have to write down the formula for the displacement of particle executing simple harmonic motion, but we have to write here, we have to just write down the simple formula y is equal to r sin omega t. Y is the displacement, r is the amplitude, omega is the angular velocity, and t is the time. Now we can define the another parameter, that is the amplitude. How we can define amplitude? Maximum displacement is known as amplitude. maximum displacement is known as amplitude. Now from the equation we see that y is equal to r sin omega t. Now this displacement will be maximum if now y is equal to r. Here we can say that y is equal to maximum if sin omega t is maximum and sin omega t is maximum if sin omega t is equal to 1. If sin omega t is 1, then y is maximum. So putting this value, y is equal to, from here y is equal to r, sin omega t is equal to 1, so y is equal to r. So this is known as the maximum displacement. Y is equal to r, so r represents the amplitude of particle executing simple harmonic motion, maximum displacement.